Alright, so now we're going to continue our analysis of our landforms, whether it's a mesh, a surface, or even a series of surfaces, right? So these are all just strips of surfaces. We're going to use a very similar process to what was in one of the previous videos on analyzing these for their elevation, except we're just going to, instead of analyzing the z-values of points, we're going to analyze their normals. So it's going to be a very similar workflow process, which is great because it's easy to begin the analysis of your landform and do an elevation model and a slope analysis model almost simultaneously by just changing a couple of the components. And again, regardless of whether it's a mesh or a surface, I'll show how easy it is to interchange between them without having to make a lot of modifications. So the idea of it being very replicable is pretty straightforward. And so again, I'm going to start with this more kind of conventional landform type versus the more abstract versions, just so you get a better idea of how this works. And I've exaggerated this a little bit more to give us a more dynamic range of slope values. That was originally a lot less steep, so we wouldn't probably get as much variation versus if I just kind of exaggerate this, you'll start to see how those will vary a little bit more. So again, this is a mesh, so I'm going to go ahead and reference that first. I can go ahead and hide it. And again, I'm going to start off by deconstructing it. So just like the previous video, where I can see that I have the vertices, the faces, colors, and in this case also the normals. So this is what I'm going to actually be analyzing, the normals instead of the vertices. But like I said, you'll see just how easy it is to kind of compare the two for both an elevation and slope model. And again, I'll do something just to show you a little bit of a better idea of how these normals are working. So if I go to curve and do line SDL, so this is going to create a line based off of the direction of vectors, or in this case the normals. So I'm starting these all with all the points that are making up this mesh, and I'll use the normal for the direction, and you'll see that I get these lines that are basically running tangent or perpendicular to those areas. So you can see the areas where it's more steep. Let me just recalibrate this a little better. Have the curves going almost in a 9 or 45 degree versus the ones that are flat, almost sticking straight up. So in order to actually get a slope percentage from these, I need to compare, let me just show you one more time, these lines or these vectors in relation to the z-value to get their relative slope percentage. And so I can go to vector, vector, angle. So I'm going to measure these, all these angles of my mesh in relation to the z, because if it's matching the z, which is going straight up, then that means it's pretty flat. Versus if it starts to vary from that, it's going to indicate that percentage slope. And so this is going to give me the angle in radians, which I'm not too familiar with on how to understand that relationship between different radian values, but I do know percentage. And in order to convert this from radians to slope percentage, I need to do a little bit of trigonometry, which can be achieved with just some of these components. So I can just find the tangent of these radians. In reality, the calculator for converting degrees into percentage is that you find the tangent of a degree instead of radians, which you would think that you could just always convert these from radians to degrees, but these components are already built to actually be looking for radians instead of degrees, so it already kind of does one of those additional steps. So that's why you don't want to actually plug in the degree component, which if you look up calculations or calculators on how to convert radians to slope percentage, it's going to say to first convert these to degrees and then you find the tangent. This already kind of has one of those steps embedded into it, so don't worry about that. It took me a while to realize that when I was first starting this process a while ago, but so I kind of just remember that. So this is going to give me the slope percentage in decimal format, so I actually want these to be in percentage values, so 0 to 100 or even greater, but this will actually convert them into slope percentage. So this is going to take a second because I think it's analyzing quite a bit of points, approximately close to 500,000. So in order to actually kind of get a better idea of this, I can look at the bounds. So what's the flattest area, what's the steepest area? And you'll see something that comes out of this one at least, which is kind of interesting. It says that there's a negative 9,000% to 626%. So these could really screw with our representation. So whenever you start to get some of these obscure values, we can begin to cap them to give it a little more accurate representation, because those can distort it. Because, for example, if there's only a few of these really kind of high values or low values, then it's going to register those as the kind of primary points where we really don't need to know that. So we can essentially cap these at a certain range so that we know that anything above 100% is going to be treated the same, because usually when it comes to a slope analysis, once you get to that steep, everything is pretty much going to have the same type of impact. So it really doesn't matter whether it's 100% or 626%. So I'm going to also apply some of that information too. So what I can say is use this minimum to say return the lesser of two items, and also use the maximum of two items. So I'm going to first kind of cancel out those negative values. So I can plug this in here and say if any of those values that are less than 0, return them as a 0. So that's what it's saying. And you can see that when I plug this into there. And it's taking a while because of just the number. So return the greater of two items. So obviously 0 is greater than a negative value. And then I'm going to do a similar thing where I'm going to say anything that's less than 100, cap it at 100. And obviously you could always change these to be of a higher percentage if you want to do something like 200%, but anything that's around the 100% slope or 45-degree angle is going to be just as important as anything greater than that for most landscape analysis. So now I've got that. So now if I were to look at my bounds, you'll see that I'm now between 0 and 100 versus the original being between negative 9,740 and 626. Oops, let's go ahead and keep that, because again, instead of the previous one where we analyzed the z elevation, z values of our vertices, now it's these values that are going to get plugged into our color gradient. So I'm going to also deconstruct these. So instead of just seeing 0 to 100 as a domain, I can actually see these as separate outputs. So there's my 0, here's my 100. And now I can go back to parameters, use this color gradient. So I've got my start domain, or my low value, which goes into my lower limit. And then my end of the domain, or my upper limit, going into there. And then all the percentages going into there. So that's coming out of this minimum one. And again, I'm going to change this to be a different preset. So something more like this. So that green means flat, red means steep. And now I can go back to constructing my mesh using the same outputs from that as my input. I can turn that off for now. And then convert or use this color gradient for my colors. Now you can start to see just how many of those areas are really steep versus their relative flatness. I can always change this to be a different preset, right? So I usually like to kind of stick with something with only a couple of these kind of intermittent sliders, so I can just edit some of these. So maybe, again, maybe it starts off with something more on the cyan or teal color. Again, it's analyzing a lot, so it's taking a minute here. Let's make this kind of this magenta purple color. So now I've got my color gradient for my slope. You can see that if I were to actually change the steepness or the scale of this, that its areas aren't going to be nearly as kind of, it's not going to have as much of a range to it. And I'm hoping this produces something a little bit less than 100%, because I do want to show you something in that case. Because again, we always kind of want to use a color gradient between 0 and 100. So if our slopes are less than 100, it's actually still going to register those values. So I can still see that my end is now, okay, so good. So there is still a high range. I don't know where those are. I don't see a lot of pink. Oh, I guess, so right here. So here's an example of those areas where they're kind of just skewing everything else, which is unfortunate. So what we can do is start to, again, kind of increase this to give us more of those purple values. You'll see how long or how much I have to do it in order to do that. Come on. It's really starting to lag a little bit here. So I can always adjust that color gradient to get more of those values. So one thing you might want to also keep in mind, instead of using these bounds here, again, it's not really going to matter for this, but it's always kind of good to actually just say that regardless of what my range of values are, to always use something between 0 and 100, so that it will fit those values somewhere in between it. Yeah, it's going to give me the same thing, but because there was still values on the 100%, but if it's ever really flat, it'll kind of correct it within that range. So there's that, and again, I can just as easily apply this to a surface. So I'll go ahead and reference the surface. Let's just move this over a little. So I'll convert my surface to a mesh. You'll see that this actually should be much more easy to process because it's not nearly as much going on. Let's just go ahead and hide that. So there's our color grading. Again, it's kind of messed up with this, but I can always adjust these. So again, so what's good about this, and it's kind of helpful to use this range of 100, 0 to 100, is that it'll match our color gradient. So we know that 100 slope percentage is this. If we ever want to add them within like specific intervals, we could always kind of go in 20 or 10% intervals just to kind of get a better range. Because again, some of these things, like when doing these analysis, sometimes it's important to know things between 0 and 30% in certain intervals versus once you exceed a certain percentage, then everything kind of gets treated very similarly. So we can start to see that. And if we wanted to do it for multiple surfaces, I could always just say set multiple surfaces, select all these. And again, we just have to remember, actually it should be okay. So, because it doesn't really matter what their relationship is to all of them, it's just, it's fine either way. So you can see areas that are really steep versus areas that are flat. I'll show you again. It doesn't, even if you want to take this surface and tile it in Lunchbox, let's try something like this. Hopefully it likes it. Appears so, right? Oops, let's use this surface instead. Right, so it still looks like it likes that surface, so you can always hide it. And let's just turn this off for now. Right, so it's kind of this geometric kind of panels. I can always increase the density. To get varying kind of results, like that kind of looks interesting in itself. And so in this case, for analyzing the surface, it's a little bit different than this, but I'm gonna still use the same kind of process. So I'll move this all around. So I don't need that. So I'm gonna take these, find the area, to essentially find these center points. And from here, I'll do a little bit of analysis on my surface. I need to evaluate my surface. So these are the panels. Then it needs these UV values. So I need to find the surface closest point. So it's asking for the surface, which are these, the points, which are my center points. That's going to give me my UV values. Okay, and it's going to show you the plane of everything, so I'll just turn off that. I don't need this. So again, similar. I've just, instead of using the mesh normal, I'm going to use this evaluated surface normal. No, I'm not doing it for a mesh, but everything else is going to stay the same. I'm going to go ahead and just change this because I really don't like this color gradient. Let's do something like this. And so now I'm going to colorize all these panels. So I'll turn this off, go to Display, Custom Preview. So this is the geometry I want to color. And these are the colors I'm going to use. Alright, so again, yellow or this kind of really bright pink is, or bright green is going to be our steep areas versus that's flat. If you want to use something a little more relatable, here's this. And again, I always kind of like to use my own kind of color spectrum, preferably more in the kind of cooler range. So now we can start to see how that looks like too. Then again, it doesn't really matter what type of panel you use this for. Let's try something else just to show a little more variety. This could be interesting. So, because I know this isn't going to actually give me surfaces, but maybe that's not what you want to analyze. So I still have these interesting hexagon patterns. I've got my cells and I've got the center point, so I actually don't need this anymore. But I still want to, let's go to surface and use a fragmented patch. I mean, if you want to, you can, but you can see that they kind of are made up of a series of geometry in order to make that, but I want to use this to still kind of do my analysis. So surface needs the UV, so I'm going to use this also. And the centers. Ooh, I guess it doesn't like that fragmented patch. So let's see how we can get these normals from these points. I don't think it'll like this, but we'll try it anyways. Nope, doesn't. Let's try this. I can still use this original surface. So what's interesting is I can analyze my surface. Let's go to curve, line SDL to still kind of show you that idea of how it's working, right? So even though I'm analyzing these center points from these hexagonal curves, I can still use the original surface as part of that to do the analysis, even though I'm not going to actually use it. So what I do want to do is use the same kind of process, but instead of coloring my surfaces, I'm going to color these curves based off of that. Oops. So that's another interesting way to do it, where you don't even have to technically analyze the surface. You could even colorize the curves. Fortunately, you can't really bake these without an additional plugin into Rhino, but it's still something worth considering. So there's that to kind of create an interesting slope analysis using curves. And again, if I wanted to do it for this, I think I already showed it, so I'm not going to bother, but, well, let's just for the sake of this do it. So I can go ahead and let's just copy and paste this. I just have to change a couple things, so set multiple surfaces. And again, it's going to use that lunchbox component on it, so it's going to take a minute to process that. So I'll just go ahead and get rid of it. And then I will so the best way to do it with this, again, I don't recommend doing it with surfaces. It's just a little bit tricky. I would just rather convert these to meshes and then run the component, so let's not worry about that. But yeah, so here you go on how to use the slope analysis. And again, if I want to, I could use either meshes, surfaces, or a series of surfaces.